Okay, so we're going to talk about this is a base E. E represents a number. It represents approximately 2.718. Although it is an irrational number like pi, if you were to look at what E actually equals, there is a button that's just plain old E and not E to any power. So let's look at where that is. So I'll just show you. If you look at the division symbol, right underneath it, there's a little E in blue. If you push second E, and then notice it doesn't like raise it to a power, this is what E actually equals. And if you push it, it's a repeating decimal and it goes on forever just like pi does. But this does have a repeating decimal, but that's approximately what E represents. So if I were putting it in positioning of the B number, that's what it kind of represents. It's bigger than 1, so it is a growth. And it's like 2.7 times what you normally would have, because technically that B number would be 2.718. Okay, so when they ask you questions about the growth factor is 2.718. So then you can say, well, it's 2.5 or more than 2.5 times what a normal growth would be. Okay, so that's just kind of the definition behind the base E. We're going to use base E quite a bit when we do logarithms in chapter 9. Okay, so if you look at these, we're just going to talk about you can use compound interest formulas and discover that the irrational number E will be used when you're using the PERT formula. So you kind of get an idea of why they're using it. Okay, so here if you match the equation, this is similar to y equals a times b raised to the x power, if you will. Now, these are scenarios, and they want you to focus on that b number, okay? So if it says that the population doubles every 10 hours, okay, notice that with the time, there is a consistent 0.1. So the one that has 10 in it probably will not be used. Okay, so if a population doubles, which one has a b that doubles? Which function? K. That one doubles, but the 10 is throwing you off because each of these has just 0.1. So this one probably won't be used. This one is doubling, so K of t is what matches to that scenario. Okay, what about the next one? And 400 happens to be the A number, that's the initial amount. That is pretty consistent in every single one. Okay, the amount of medicine in her bloodstream decreases by 25%. So out of the remaining 3, which one decreases by 25%? H, right? Because isn't this 1 minus R? And if you're decreasing by 25%, R is 25%, so 1 minus 0.25 is 0.75. So H would be B. Okay, what about a half-life? A radioactive half-life. You use this a lot in like chemistry and in biology and in in your science classes. F, because half-life would be half the time, so 0.5. And then finally, the population expected to grow 25%. So which one is that? Right. Okay, so they just kind of want to give you a scenario of, can you pick out some things based on a word problem, okay? Then they're going to ask you to graph these. This is where, if you don't have a graphing calculator, you're going to have to pick values for X and get a Y value. I want at least 3 or 4 points on these, but you can certainly do this on your calculator. Okay, so These are all exponential functions because the exponent is the x, okay? Now, growth and decay. Growth means it starts low and then increases high. All right, so the B number here is 4. What's the B number on this one? 2. So we would expect this one to be half as much, right? What about the B number on that? What did I say E represented? 2.71. So wouldn't you expect this e to the x to be in between? If you were graphing all these at the same time, the e to the x would be in between those. So let's kind of look at that. Let's graph these. I'm going to do them in different colors. All right, so the first one is going to be y equals 4 to the x. So use your calculator. If you don't have a calculator, then you're going to pick values for x, starting with -2, -1, 0, 1, and 2. And you're going to plug them in and get a y value, okay? But since I have a graphing calculator, I can just go to y equals and do 4 raised to the x power. And then I can graph it. Now it's going to level off. It doesn't stop there. It starts to level off at x equals 0. So you can continue it because these are continuous graphs. Let's go to the table and see some of the negative values. See how it's getting really close to 0 as you go negatively? I wouldn't expect you to plot these decimals, but I would expect you to get pretty close to it. Okay, so I could plot -1 and 0.25. That's just like a little less than a half. -1 and 0.25 is right there. Then I've got those points that are getting really close to 0. And then I'm going to go to some other points. Maybe 0, 1 would be a good one. Then I could do 0.5 and 2. That would work. At least I have some points that I could plot. If you have to go in between, go in between. 1, 4. 1.5 and 8. 1 is at 4. 1.5 is at 8. And that's probably all I would do for that one. Okay, so that represents y equals 4 to the x. Now I'm going to do y equals 2 raised to the x. Since we know that this one's going to be in between those two, I'll do this one next. Y equals second ln, that gives you the e, and then it would raise it, second ln, and then x. Okay, then push graph. It's going to be pretty much the same, but except there'll be different points. So second table. Okay, so this is getting close to 0.5, negative 0.75 and 0.5 would be about right here. 0, 1 is definitely on there again. 1 is at like 2.7. So about right there. Now 3 is way up here at 20. Okay, so I would just come close to that and go up. There'll be arrows on both ends because it is a continuous graph. Now y equals 2 to the x will be after that. So let's go back to y equals. We can put 2 raised to the x. Push graph. Okay, it gets a little bit wider out here. So go to your table, second table. Let's go back. So we're getting pretty close to some of the same points, except for 0, 0, 1 is the same point, but then it starts to flatten out. 1 is at 2, 2 is at 4, 3 is at 8. So here comes the last one. 3 is at 8 up here. So those would be your 3 separate graphs. And so you could make a, what do you notice about each graph? They are all exponential, and e to the x is in between the 4 and the 2, because the base number is a little bit more than 2.71. So that's what you notice about each of the graphs. Now we're going to continue to use our calculator. These are the problems I'm going to put on your quiz and test. These example number 3 problems. So copy them down so you have something to look at. Properties of exponents. Looks like we're going to have a lot of negative exponents here. What do we do with negative exponents? Do you remember? Do you leave negative exponents in your answer? No, where do you put them? In the bottom, in the denominator. Okay, if they're in the denominator, where do you put them? In the numerator, exactly. You flip-flop them, right? That was the first question on your test last week. Okay, so here, if we raise this, this is e to the negative 3x, which becomes 1 over e to the 3x. When you put it in the denominator, the exponent changes. Now, we can't really use our calculator on this one because we have an x in there. So they wanted you to use your calculator if you can. For example, this one we can, but properties of exponents when you can't. Like that. Okay, so the next one, we could actually put in our calculator just as we see it. You don't have to, unless you don't want to put the division part in. Technically, you would put it up here because it's a negative e, a negative exponent. So you could type in this, or you could do 1 over e to the negative 2. It makes no difference because it says the same thing. All right, so let's go, let's just do e, 50 second ln to the second power. And that's going to equal 369 point, let's go with 2 decimal places, 45. So if you did just as the problem showed you, you could see you get the same exact answer. Okay, what about this one? This one, it looks like we can put in the calculator. Again, parentheses, you could put all this, parentheses raised to the negative 2 power if you want to. If you don't have a graphing calculator and your calculator is not so great on doing that whole parentheses thing because you don't have parentheses, then you're going to have to raise it here and raise it there. So this would be positive 4, so this would be 12 to the 4th over e to the negative 2. If you want to move that up to e to the positive 2, then those of you without a graphing calculator can just type it in like this. 12 raised to the 4th times e to the second. Okay, so we're rounding to 2 places, so that's going to be 47. But really, it's an easy lesson because it's really calculator work. But make sure you're doing it properly. I mean, calculators can give you wrong answers if you don't type them in correctly, okay? Okay, the last one, let's just talk about this word problem, because there is a word problem you're going to have to kind of talk about. Especially the equation they're giving you, remembering what E represents. The medical technologist observes a certain type of bacteria multiplying at an alarming rate. The growth of the bacteria is represented by G of T equals 3,000 E raised to the 0.25 T, where G of T is the total number of bacteria present after T hours. Describe the growth rate of the bacteria based on the function. Which one represents the growth rate? E is the growth rate. And it is 2.718 greater each hour. Because that's what E represents. So it's growing at a rate of 2.718 per hour. How do you describe how fast the bacteria is growing to a friend who doesn't know about E? Well, you could say it's more than 2 times, or more than doubles each hour, because E represents 2.7, so that's more than doubling per hour.